Okay, ladies and gentlemen, welcome to another episode, if you will, of the Parsippany Green Team. This one is about energy saving improvement plan. And Matthew Cavanaugh will be our host for this evening. Matthew, take it away.
Thank you. Yes, so this is hosted by the Parsippany Green Team in alignment in conjunction with the Parsippany Troy Hills Public Library. The Parsippany Green Team is a team that was formed to pursue certification in the Sustainable Jersey program. So we were voted by resolution to pursue certification in the program. And our mission of the Parsippany Green Team is to collaborate with our residents, town government, and business community to identify and implement programs that improve our quality of life and the physical, environmental, and financial stability of our community. So across the board, sustainability is all aspects, people, planet, and prosperity. And Sustainable Jersey is a program that encompasses all of these aspects. So this specific library series is on Energy Savings Improvement Plan, also known as ESIP, and we'll jump right into it. So at a very high level, these are the goals of the Parsippany Green Team. The Sustainable Jersey program is a points-based system, and there's over 400 actions in the program. Each action is worth a certain number of points. And when you complete the action, Sustainable Jersey reviews those and awards you points on any given fiscal year. So 2021, we're after 150 points or bronze certification. In 2022, we want to get silver, which is 350 points. And then we're also going for gold in 2023. Which is the gold certification in energy and is a function of greenhouse gas reductions across the town and the community. But Sustainable Jersey, as I mentioned, is multiple categories of sustainability. These are the large 18 overarching categories. So you can see animals, arts, energy, food, natural resources, local economies, waste management, community and partnership outreach, diversity and equity, health and wellness. There's a whole bunch of different aspects of sustainability, and targeting just one of these does not create a sustainable community, but targeting actions across a broad spectrum makes your town more sustainable and also improves the quality of life. So for the team membership, we are looking for people to step up and participate in the program. And if one of these areas is of your interest, then we'd like you to speak up and get in communication with us, and then we'll figure out how you can help. But basically, here is the start with why. Climate change is having a big impact right now and requires everybody's actions today. This is a graph of greenhouse gas emission reduction targets across the world to maintain a 1.5 degrees Celsius global temperature raise. So 50% reductions is required by 2027. So this inflection point right here, this red graph, shows that the longer we wait to reduce our carbon, the more we have to reduce over a rapid time period to stay within the threshold. And that's kind of where renewable energy and some of the ESIP program comes in. So solar PV, geothermal, and wind are cheap, they're safe, they're abundant. In fact, 1 minute of sunshine is equal to 1 year of human electric consumption on the Earth. And they also require very little water and afford energy freedom and resiliency. So this graph right here from Our World in Data shows that hydropower and solar and wind virtually don't even show up on the map here in terms of safest sources of energy. And these are fatalities for every megawatt hour produced. So very safe, and we'll get into some of the designs that we put together a little shortly. And then again, Parsippany and its citizens can really be a leader in this space. So if you're looking at the effects of global climate change, you can see the mean temperature continues to rise year over year, and our state is one of the highest in the United States for the actual temperature impact. Atmospheric CO2 is above 400 parts per million, and this is from 280 parts per million in 1850. And then anthropogenic greenhouse gases emissions from burning fossil fuels is from the IPCC is conclusively where this is coming from. So any number of these graphs, if you look at them, you'll see the increasing rise of temperature, and that's where the ESIP comes in and some of the solutions. So the action that we're going to talk about is energy efficiency for municipal facilities. And this is an action that is one of the gold star actions in Sustainable Jersey in the energy category. It's worth 50 points, and it requires a tracking and reduction of greenhouse gases for municipal facilities across the township. Some of the other gold star actions include electric vehicles, solar, geothermal, across commercial buildings and citizens in the town. But these gold actions are all designed to reduce the footprint, carbon footprint of the town over 3 years. So again, this is why it's a 2023 year goal, because it takes some time to reduce the carbon footprint. So how does that tie into an energy savings improvement plan? Well, in a nutshell, an energy savings improvement plan is a financing mechanism which allows retrofitting of facilities with energy conservation measures, or ECMs, with no upfront capital expenditures to the town. So we passed a resolution in 2020 to open up a RFP for the Energy Savings Improvement Plan. So this is signed into law in 2009 through the BPU, and New Jersey Clean Energy Plan program regulates it. But basically, the energy conservation measures total up to a net savings of utility expenses for the buildings. So an energy services company known as a ESCO, there's only 14 that are approved in New Jersey. And the RFP will go out to these ESCOs, and they will look at the aggregated potential of all the buildings and estimate what conservation measures could be put in place to reduce utility expenses. And essentially, the future value of those energy savings are leveraged to pay upfront costs over a 15 to 20-year project lifecycle. So implementing the plan now is important because it will take advantage of the federal tax credit for some of the solar and also existing programs in New Jersey Clean Energy Program. And then legally, the program has to be cash flow positive for the municipality from year one. So up here in the upper right-hand corner, you can see some savings examples. This big black box is the utility bill expense before, and this is an example. During the repayment term, during the ESIP program, so this is the 15 to 20-year term, you basically have lower utility expenses through the energy conservation measures. You have a repayment of financing, and then you have positive cash flow from the net reduction in expenses to the utility. And then after the ESIP is finished, you've essentially paid the term through the energy conservation measures, and at that point, all of that is cash flow positive to the utility. So 15 to 20 years from now, these measures are still going to be in place and have a useful life to them, and the town will benefit from all of those utility savings. So step number one here in terms of the timeline is already complete, and you can see the process over here in the bottom right-hand corner. We completed this initial energy audit for the entity buildings, and we started tracking all of the utility bills for the municipal facilities in 2019. There was a fellowship program where someone came in and helped aggregate and find all the bills and then come up with the utility expenses and also the carbon footprint for these buildings. And we'll share that a little bit later. But we started energy tracking management in 2019 and then submitted what's called a local government energy audit. So this is a program through New Jersey Clean Energy Program where if you track and manage all of your energy expenses, you can apply for an audit through New Jersey Clean Energy Program, which will come in and do an assessment and evaluation of your municipal buildings for some of these energy conservation measures and look at and audit every single building in the portfolio. So the audits, or the LGEA inspections and audits took place in Q4 and Q1 of 2020. And then in Q2 of 2020, we had an exit interview, which enabled us to pass a resolution and move on to step number 2, which is issuing an RFP to the ESCOs, energy services companies, for the municipal buildings. And then kind of give you an example of some savings. Here's Pittsgrove, West Milford Township of Montville, Denville. These are in the millions over 10, 20 years, 15 to 20 years. So, the savings really stack up. And as I mentioned, after the term is repaid, then the savings actually increase even more. So let's get into some financing. So how is this no cost to the township? And basically, there are 2 commonly used options for financing: a lease purchase agreement and a refunding bond. So a refunding bond, you don't need debt, which is available through the ESIP. The refunding bonds are likely to be less costly overall, but they require an ordinance, a public hearing, and approval from the local financing board. And the other example here is a lease purchase agreements. So no ordinance are necessarily required for this, but the agreement can be entered into directly by the local government unit with the ESCO or private financing party. In both financing options, the maturity schedule for energy savings obligations must not exceed the estimated useful life of the individual energy conservation measures. So they basically here are taking construction costs, soft costs, the average repayment, the expected savings from the energy conservation measures, and then coming up with a 15 to 20 year schedule, including some interest. But then over time, you can see the net cash flows where the benefit flows in part to the municipality. And then finally, after the term, it all becomes savings for all of the utility expenses. So it's a great way for the town to get started on some actions for these energy conservation measures through a state-approved program and start reducing the carbon footprint of the municipal facilities. So as I mentioned, we're on phase 2, or step number 2, which is to reach out to the BPU and get an approved RFP, which will go out to the ESCOs, and then we can start the process of a more detailed audit of the buildings. So energy conservation measures, what does that actually mean? So these are some examples: energy efficiency equipment, demand response equipment, combined heat and power, renewable energy, water conservation, building envelope improvements like insulation or windows, control systems. So these are a measured reduction in fuel, energy, operating, or maintenance costs resulting from the implementation of one or more energy conservation measures when compared to an established baseline of previous fuel expenses. So that is the measurement of savings that is used to plug into the model for how much you're actually saving over the 15 to 20 years. These are the lists of ESCOs per the BPU. So this is the Division of Property Management and Construction, has a short list of approved ESCOs. So Johnson Controls, Honeywell, George S. Hall, Ameresco, Willdan, Tran. These are big companies that know what they're doing, and they can come in here and help with this savings plan. So process detailed here. Step number 1 is complete LGEA energy audit. Step number 2 is determine the method of implementation. We believe this is going to be a full ESCO project, so we're not going to do any do-it-yourself type examples here. Step 3, issue the RFP to ESCOs, do the investment grade audit. So this is much more detailed than the LGA audit. It's a level 3 audit that goes much deeper and starts to do some of the engineering and calculations for the savings. Step 5, draft the energy savings plan. And then finally, this goes to the BPU and the municipal entity for approval. So ultimately, the plan will come before the town council for vote and be scrutinized and reviewed to see who we want to go with, or in fact, which plan we want to go with. And then there's the financing through refunding bonds or lease purchase agreement, finally construction, and then commissioning. And we have the option of measurement and verification, which means we can, on an annual basis, verify the savings that we're expecting, measure and verify them so that we are in fact getting the savings that we were expecting. So that being said, we can get into a little bit of the energy tracking summary and the carbon footprint of the buildings. This will put things in context in terms of potential solutions for the energy savings plan, especially renewable energy. Before we get into that, I wanted to make a plug for renewable energy. So these are a couple examples of options, which are geothermal ground source heat pumps and solar photovoltaic systems, whether they're ground mount, carport over parking lots, or put on rooftops. And all of these apply to our existing municipal buildings in some way, shape, or form. But renewable energy reduces demand with the buildings from the source, essentially producing electric on site or producing heat and cooling on site from the ground. And they offset as much of the electric heating and cooling and energy demand on the premises. And they also offset the balance with clean, renewable electric energy purchased through an aggregation program if we choose to do that in addition to the ESIP. So these are some of the renewable energy solutions that are viable and could be used in the plan. We still haven't gone out to RFP yet, so we don't have any of this built in, but it's definitely going to be part of the request. So these are the 14 municipal buildings in Parsippany, from the community center to the main library, police department, the PAL building, sewer, town hall. You can see that they're spread across Parsippany, and I have each one numbered, which I'll refer to a little bit later. But the total electric consumption, at least in the 14 months that we measured, was 8.5 million kilowatt hours over 12 months, and 134, almost 135,000 therms of natural gas was consumed by the municipal buildings. And this is a drop in the bucket compared to commercial and residential carbon footprint and consumption. But it is something that we're targeting. So essentially, the Energy Savings Improvement Program will reduce the electric and natural gas consumption through the energy conservation measures. And renewable energy, if built into the plan, can offset some of this demand directly by producing the energy on site. So this is the summary by building. You can see the sewer department is a lot of pumping of water and refinement. That consumes 7.4 million kilowatt hours of energy. And this is after adding up the electrical energy and then the energy contained within the therms of natural gas. So we converted therms into the total consumption of gross energy in kilowatt hours to come up with this table. And then you can see the costs on an annual basis and also the tons of CO2 emitted by each facility. So in total, the gross energy consumption was 14.7 million kilowatt hours, equivalent energy. That's natural gas and electric, over 4,000 metric tons of CO2 emissions. And this is just based on the carbon emissions per kilowatt hour and also the carbon emissions by burning 1 therm of natural gas. And total cost is 1.1 million. So huge consumption, huge carbon footprint, and definitely a great opportunity in this program to save some costs. So here's just a plot of the energy costs by month. You'll see a spike in the winter time when natural gas is consumed for heating in our area. But it's about $80,000 per month from energy that's needed to run the facilities. And again, this is very small compared to the larger community, but we plotted it here. And then here is the greenhouse gas emissions over the same time frame. So from March 2018 to April 2019, as I mentioned, over 4,000 tons of greenhouse gases. You can see the spike in the summertime driven by the natural gas again, and then there's some oil consumption as well. But the emissions peak in the summertime, and then they kind of go down in the spring. So I wanted to mention this about New Jersey at large. So this is a energy consumption Sankey flow from Lawrence Livermore National Laboratory for just New Jersey. So the flows, these on the left-hand side are the generation means or the gross energy inputs into the system in New Jersey. And then the electric generation is the orange up here, which shows a good portion of our carbon footprint is coming from the natural gas fed into the electric generation. And then the other portion in New Jersey specifically is coming from transportation. The much larger portion is from transportation. So the commercial building, when we're looking at the ESIP and the municipal buildings, falls into this category, which are consuming electric and which are consuming natural gas. So energy conservation measures will reduce the demand in this space in the municipal buildings. So using renewable energy, for example, reduces the actual dependency on any of these fuel sources because you're generating the heat and the cooling and the electric on site as much as possible. So you're reducing the gross demand in the net system, and you're also reducing your carbon footprint at the same time. So it's two benefits. So I'll jump into some very preliminary designs. Now this is based on some estimates of the carbon footprint and the consumption in the bills. So it's relatively very close to what's potential, but still a work in progress. So for example, the sewer plant here for a path to zero carbon with solar and geothermal, again, 5.7 million kilowatt hours consumed, a 4.9 megawatt solar combination of ground and carport would potentially provide enough energy to directly offset the consumption of this facility. And then for the therms, 19,000 therms of natural gas, potentially ground source heat pumps could be drilled vertically into the ground to pull heat out of the ground and provide the heat needed for that. Now, some of this is process heat, industrial heat, which may not be fully offset, but again, this is an example. So this is an aerial image of the sewer plant. You can see the areas in blue are either ground mount or carport type structures. So south is to the bottom of the page here. So the solar is mounted potentially on this the landfill on the south slopes of the landfill, ground fixed tilt options on both sides, and then some ground fixed tilt and carport mixed throughout. So the final design will be some version of this, and we're still in the process of figuring all that out. But potentially as well, a energy storage system could be put in place so that the facility could run for some duration if the grid were to go down, to add some resiliency features to this as well. Here's some other images, just a little bit more detail. So you can see this is a different angle on the sewer plant, but you can see the slopes a little bit more. And there's a high voltage tie substation right here, which potentially you could interconnect the energy through high voltage lines potentially. The main point to take away here is that there's adequate space on the facility, on the grounds of the facility, to provide heat and electric to offset the carbon footprint of the sewer plant. And then these are very preliminary, again, very preliminary, but this is the community center. So solar on either sides of the roof, the peaked roof here, and a small carport, as well as 10 geothermal wells in the parking lot or the grass area over here could offset this carbon footprint, which is 529,000 kilowatt hours and 10,000 therms. For the Knoll Golf Club, east and west, again, preliminary. I didn't necessarily know who owned this plot of land here, but there is something where you can produce energy and then aggregate it with a meter that isn't directly connected to the solar system. And also this could be a community solar project as well, but a ground mount solar system right here, 380 kilowatt hours, could and potentially a carport option could offset the carbon footprint of the knoll east and west. Gene, this is for you. The main library, 453,000 kilowatt hours and 13.5 thousand therms of consumption. So this is a potential design where you could put solar on the rooftop of the building, assuming structurally it could handle it. And then you have a beautiful parking lot for some carport structures here without having to repaint the lines or do anything different. And additionally, there are land around the facility where ground source heat pump wells could be drilled to produce the heat needed and also the cooling needed in the summertime. Police Athletic League, the PAL building, 98,000 kilowatt hour consumption and 21,000 therms. 2 solar carports here potentially could offset that, as well as the heating burden is pretty high for this facility. So you'd need a few more geothermal wells, which could potentially be drilled in the surrounding areas. To be determined. This is all a draft. And then the police station, 666,000 kilowatt hours and 13.5 therms. Putting solar on the south or southeast or southwest faces of the roof of the police station is one option, as well as some carports in the parking lot here. Looks to appear to get some good sun. And then also geothermal wells. There's plenty of grassy areas where this could potentially be coupled in. And finally, Town Hall, you can see here, 290,000 kilowatt hours and 9.6 therms. And some carports or rooftop solutions could potentially be used, as well as some geothermal wells here. That's the end of the presentation, Gene. Do you have any questions?
I actually do have a couple questions. So we know that Lake Hiawatha, they're building a new building. Would the green team want to get in the ground floor with that and promote that, maybe we do put solar panels on this new building? I don't know if that's something that would take place when you have the option right now to, put your 2 cents in.
It's much less expensive to integrate renewable energy solutions in the initial design of the building than it is to try and retrofit something later on. The current Lake Hiawatha library consumes oil for heating. So, designing this with ground source heat pumps at the actual construction site with the building design so there's optimal solar or carport structures or something when everything is being built and the parking lot's not paved, whatever that looks like, that's a really ideal place to do it, as well as making the building have passive solar and some energy efficiency as much as possible to make sure that the consumption of the building is as low as possible, and then you need less renewable energy.
And then the other thing I wanted to ask was, you had the 2 different options. You could do the lease option or the bonds. Okay. So the bonds have to be passed by the town council, right? And so is that something that would be like you would find in our taxes? How would that work?
I'm less familiar with some of the financing mechanisms. We need to get a little bit more educated about how that works. But remember, this is a cash positive situation where there shouldn't be, I can't speak for the township or anything, but, there's savings there right off the bat. So it should be cash positive from year 1. So I don't know what's going to happen with taxes or any of that.
Okay. Okay. I just know that people get a little upset when you talk about raising their taxes, even if it's a penny a month. You know what I mean?
Well, the beauty of this program is that it doesn't require upfront, cash. So the funding is really taken on by the ESCOs, and then basically, we're still a partner in the repayment of those initial investments, but we don't have to put up the upfront capital for that.
Got it. They take that on and then we repay what they've taken on.
Yeah, but we're saving money also every month.
Right.
Every year.
Yep.
So the whole program over the 15 to 20 year lifespan has to be positive every year of the program. And again, we also have the opportunity to do measurement and verification, which means that the ESCO and a third party comes in and actually does an audit and make sure that the savings the town is expecting is actually happening.
Got it.